Yes, I know most of you see questions like this in school, and you'll be like, we have this question like this exists inside theory, set theory. Yes, it does exist, and today we are going to explain the question and how to solve it. So today, the question we have here says that given that P, set of P equals to 2x, 2x, such that 1, such that x is less than or equal to 1, x is less than or equal to 5, comma, for x is element of what? Element of integer. This set, anyway you see this z, it means what? Set of integers. So it means that the element in this set are what? Are all element of integers. Then also we have set P, x plus 1, such that x is less than or equal to 2, x is less than or equal to 8. For x are all element of integers also. You know, said all these sets are subset of the universal set. Then this is the universal set. The universal set U equals to x, such that 1, so that x is less than or greater than 1, or x is less than or greater than 10. Use the following information to answer the following question. They're asking us to find P intersection Q complement, and we should find P union Q. That's what they're asking us to find. So let's deep in and find the sets. So first of all, we have our set P here. Set P. But before I go in, let me explain what this means. Let me explain this. What this means is that anywhere you see this type of sets, what this, if you find out that if you find out always here, there is what? There is always like a linear equation here where you can put all forward value of x. You see here we have 2x, and here we have x plus 1, and here we have x. This is the formula we are going to use to solve and find all the elements in this. This is the range. Why this is the formula? Forget about this. They're just telling you what you're going to have. That an element of integer. We all know that x is an element of integers. But this is the formula which we are going to be using. We'll substitute the range of the x. For example, here we have x is less than or equal to 1, meaning that we're going to start from 1 because of the equal to 1. X less than or equal to 1, x less than or equals to 5. So as we start, our x start from the range of what? From 1 to what? From 1 to 5, because 5 is included, 1 is included, from 1 to 5. So for this formula, for this 2x, we'll come and substitute when x is equals to 1, we substitute for x. When x is equals to 2, substitute. When x is equals to 3, we solve. Then the numbers we find after substituting are the elements of P. Same goes for Q, same goes for the universal set. Now let's dive in and see it in action. We have 2x, right? So for x equal to 1, for x equal to 1, that's the range, because let me write it, range equal 1, 2, 3, 4, 5. That's the range of this. So we'll start for x equals to 1, P is equals to 2x, then we substitute 1, it will now be 2 times 1, which is equals to what? 2. Then for x equal to 2, we're taking this range now, P is equals to 2x, then we substitute the 2 now, 2 times 2, which is equals to 4. Then we come again for x equals to 3, P equal to, for x equals to 3, P equal to 2x, which is equals to 2 times 3, which is equal to 6. Yes. For x equal to 4, P is equals to 2x, that's the formula. Then we substitute for x now, which is what? 4. Then we have 8. Then for x equal 5, which is the last range we have, P is equal to 2x. Substitute for x now, which is 5, then we have 10. So this 2, 4, 6, 8, 10 that we have now are now the new elements of P. We'll now come, let me do this. P, set P now. In set P now, we now have 2, 4, 6, 8, and 10. These are our new elements of P. Like I said, this is the formula. They give us range, then we'll solve for the real elements of P. So let's go for Q. For Q, the formula for Q here, we have what? X plus 1. X plus 1. So x plus 1. And the range, let me say range equal, the range is starting from, the range as you can check, see here, start from 2 to 8. So the range starts from 2, 3, 4, 5, 6, 7, 8. That's going to be the range of this. So I'm going to substitute for each of this now. So like I did earlier, we are going to start for Q equal to 1. Q is equal to x plus 1. We substitute now. 1 plus, when Q is equal to 2, sorry, because I started from 2, that range started from 2. So substitute for this now. 2 plus 1, which is going to 3, right? Then you don't need to write for x equals to 3 again. You can just do a direct substitution, like Q is equals to x. We know that now our new x now is what? 3 plus 1. 3 plus 1, we're going to have 4. We take the next one, which is 4 plus 1, we'll have 5. The next range, which is 5 plus 1, we have 6. Next range, 6 plus 1, we have 7. The next range, 7 plus 1, 7 plus 1, we have 8. The next range, Q equal to 8 plus 1, which is 9. So now that we are done with it, we'll now come and write the elements of 9 now. So now we'll now write the elements of Q that we find in you. Set Q, we'll start adding from 3. We have 3, then we have 4, then we have 5, we have 6, 7, 8, and 9. These are our new elements of what? These are our new elements of Q. So going on to the universal set. The universal set, the formula for our universal set. The formula for our universal set is what? Is only x. That means when you're substituting for 1, you just move the s, you put 1. Substitute for 2, move the s and put 2, because the range, as you can see, the range is out from 1 to what? To 10. So when you're substituting universal set, you don't really need to worry ourselves, because if you substitute from 1 to 10, it's going to give us 1 to 10. No need for writing it, just write our universal set starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's our universal set. So we now have set P, set Q, set 1. Let me write them all together so that we can see them clearly. P here, where we have 2, 4, 6, 8, 10, and set Q, we have 3, 4, 5, 6, 7, 8, 7, then 8, comma, and 9. That is all. So these are our sets. Like I said earlier, they are going to give us this in form of this. Then we are going to transform them using the formula and range they give us. We want to transform them and have our real elements of the sets. So they ask us to find P intersection Q complement. A, find P intersection Q complement. In my last video I explained this, that this means complement. Anywhere you see this mean complement, or anywhere you see like C like this on top it, both of the same, it mean what? They mean complement. So if I want to find P intersection Q complement, it means that we should join the element of P and Q and remove it from the universal set. What we're going to do first is that we are going to find P intersection Q first, then later we'll find the complement. So, but first find P intersection Q. So P intersection Q, we'll now check what intersection means. That it means that a number that comes out here it appears in set P and also as set in set Q. So if you're going to check, 2's appear but not appear here, but 4 did. So write 4. If you continue checking, also 6 also, then I think 8, yes, 8, and that is all. 4, 6, 8 are the only number that appear here and also appears here. So now that we have our P intersection Q, let's find the complement. Complement means that we should remove this from the universal set. Like we should remove 4 from here, remove 6 from here, and remove 8 from here. Then the rest is the complement of what? P intersection Q. Then P intersection Q complement is equal to, if you're going to remove 4, 6, and 8, we'll now have 1, we'll have 2, we'll have 3. I'm going to remove 4, I'm going to jump it and we'll go to 5. 6 also, I'm going to jump it and go to 7. 8 also, I'm going to jump it and go to 9. Then 10. That's for the what? That's for the complement of what? Of P intersection Q. First of all, what I did, I find what? Find P intersection Q. Then after you find that, move it from the complement. That's going to be the best way without you mistaking. That's how it should be done. Then B said find P union Q. P union Q means that we should join these numbers together without repetition. Like P union Q equal, it means 2 is here but 2 is not here. Write it once, right? We join this number and this number together but without repetition. There is 2, there is 3, 4 appears 2 times, but we're going to write it what? Only once. That's what it means without repetition, meaning that if it appears here and here, you only take one of it. Then we'll go to 5, then 6, 7, 8, 9, and 10. And that's P intersection Q. The number at what appears here and appears here. It's like joining the both elements together in ascending order, but without repetition. Meaning if, like, say 8 appears 2 times here, we're going to write only 1 8. Same goes for 6, same goes for 4. Then the rest would add them in as an ascending order. And that is that for today's video. Thank you for watching.